Okay, so now we've come to it. These vector fields, which I keep saying might be important or definitely will be a big part of the chapter, especially if they're conservative. How could we find out if the vector field is given first that it might be conservative? So this particular vector field is written with two components. So we have the f of xy is m, which could have two variables in it, and n, which could have two variables in it. And we won't cover this until later in the video series, but if there is a three variable vector field and there's three partial derivatives, then there is a third component that's called capital P of xyz. That'll show up later on. So how do we know if this is conservative? So let's go back and remind ourselves what exactly does that statement mean. So if we have a conservative vector field, that we know that it came from the gradient of a function, and so there'd be a gradient of some function of x and y, and that first component would be the x partial derivative of that function, and the second component would be the y partial derivative of that same function. All right, so that would be if we did a gradient. So we know the definition of conservative is that the conservative vector field, right, that means that it came from the gradient of some function. So by looking at these pictures we've got here, we can draw some little quick conclusions. First of all, that means these two terms are equal to each other, that the x partial derivative is called m, and that the y partial derivative is called n. And so that would be a clue to working in the direction of how do we make the test. Now, we're going to tie that together with some information we learned earlier in the course, but let me just write this statement out here. If capital F of x and y is conservative, then we know that the x partial derivative would be equal to, it's up here a little bit, the m term, and the y partial derivative would be equal to the n term. So I said it, now I've written it, so you know I made it for sure now. So here's the fact that came earlier in the course that we're going to capitalize now. So from previous information, we know that if we were to have a function, if we have some function of x and y, and I'm going to write smaller now, then, or simpler I should say, we know that if you start with the x derivative, that may not be equal to if you start with the y derivative. But if you start with the x derivative and then take the y derivative, that's equal to if you start with the y derivative and then take the x derivative. So these were called the mixed partial derivatives, and that's from earlier in the course. So let me shed a light on that. We just found out up here that the x partial derivative is also called m, and the y partial derivative is also called n. So I'm going to rewrite the statement that we have here. That means if we started with m, which is the x partial derivative, and take its y derivative, that would be equal to if we started with n and then follow it with its x derivative. So we'd have to scroll through the last few phrases to see all that connecting together from what we had at the very beginning, and where you can see the red highlights here, which are now going to be some green to go with it. So this little piece of information here is sort of the magic trick that we're going to have to do. This is the piece of information. So I'm going to write it out as sort of a statement then. If capital F vector field is conservative, then we could take the first component called M, take its y derivative, and that should be equal to the second component's x derivative. If those are not equal to each other, then that means the vector field is not conservative. And so what we're looking for is if this is going to happen, then we know that these two facts are equal. If there's only two variables and two components, you just sort of check these opposite or mixed partial derivatives. If there are three components, there are more checks to make, and we'll discover that a little bit later in the series. There you go. This is a big fact. We're going to start to practice it next.